In the previous videos, we were introduced to fluid flow and how to calculate flow rate. Now we are going to look at some applications of fluids. For an incompressible fluid, the volume rate of flow is going to be the same past every point in a pipe or stream. This means that the speed of water is faster where the stream or pipe is narrower, and the speed is slower where the stream or pipe is wider. This makes sense if you have ever taken a hose and placed your finger over the end. The water seems to shoot out faster than if you just let it run out the end. Since you are restricting the hose, the speed of the water must be faster in order to keep the volume rate of flow constant. This means that V1 times A1 is equal to V2 times A2. The speed multiplied by the area is constant in an incompressible fluid system. If V1 increases, then A1 decreases, and if V1 is faster, then A1 is smaller, since a smaller area gives you faster volume rate of flow. Bernoulli's principle tells us that for horizontal fluid flow through a tube, the sum of the pressure and the kinetic energy is the same at every point along the tube. We can take the idea from the last slide and see that if a fluid moves through a wider area, it travels slower. If it travels slower, it will have less kinetic energy. If the kinetic energy is lower, it must have a higher pressure in order for Bernoulli's principle to hold. On the flip side, like by point B, if we have a smaller area, the speed is faster. If the speed is faster, then the kinetic energy must also be higher. If the kinetic energy is higher, then there should be lower pressure to keep pressure plus kinetic energy constant. In the next video, we will look at some practical examples of Bernoulli's principle.